In this video, we're going to take a look at how to convert from particles to mass and also from mass to particles. So we learned how to use two main formulas. We learned to use a mass formula, which is mass is equal to the moles times the molar mass. And we also learned how to use the particle formula, which is equal to number of moles times Avogadro's number. What you'll notice is that there's no direct formula to go from mass to particles and from particles to mass and from mass to particles. So what you have to do is you have to use both of these formulas, and you'll notice there's one common element between them, the number of moles. So if you're given the number of particles and you want to convert to mass, you first have to convert to moles first and then convert to mass. If you're given the mass and you want to convert to number of particles, you convert to moles first and then convert to number of particles. So the goal is basically the mole. Every time that you want to convert from particles to mass or mass to particles, first convert to moles and then do your other conversion using your other formula. So let's take a look at an example of this. You're given 2.54 grams of hydrogen sulfide, so H2S. It's important that you remember how to make formulas for compounds because you need to know what the compound looks like in order to get its molar mass. So you're given 2.54 grams of hydrogen sulfide, 2.54. Put your units down. You're asked how many molecules of H2S are there in that mass. So you're asked for the number of particles. You know that the number of particles is going to be equal to the number of moles times Avogadro's number. To use this formula, you need Avogadro's number, which you have, you know it, and you also need the number of moles of our hydrogen sulfide. So what we need to do is figure out how to get the number of moles of hydrogen sulfide. Well, you have the mass of hydrogen sulfide and also the molar mass of hydrogen sulfide. If you go in your periodic table, you can find the molar mass of hydrogen sulfide, which is 2 times 1.01, because there's 2 hydrogens, plus 32.06, because there's 1 sulfur. And so the molar mass of hydrogen sulfide is 34.08 grams per mole. And so what I can do now is, because I have my mass, my molar mass, I can convert the mass to moles using my mass divided by molar mass formula. And so that's going to be 2.54 grams divided by 34.08 grams per mole. Cross out grams, you're left with moles, and you get 2.54 divided by 34.08, and that gives you 0.0745 moles of hydrogen sulfide. Now that we have the number of moles, we can, so little n, we can convert to big N, the number of particles, because we have everything we need to use our formulas now. So we have big N is going to be equal to 0.0745 moles multiplied by 6.22 times 10 to the power of 23 particles per mole. Now we're dealing with particles of H2S, so I'll just put H2S per mole. You have mole over mole that can cancel out, and you're left with H2S molecules. So 0.0745 times 6.022 times 10 to the power of 23, all in brackets there. And that gives us 4.49 times 10 to the power of 22 molecules of H2S in 2.54 grams. So I had to convert from mass to moles first, and then from moles to particles after. The common link between the two formulas is the number of moles. So the goal is to convert to mole and then convert to whatever you're looking for. We'll try one more problem together. Let's just erase our screen here so it's a bit neater to follow. Okay, so the next question, and we'll have our formulas follow us, which is great. The next question is, you're given 1.3 times 10 to the power of 28 molecules of NO2, so that's the number of particles, big N, and you want to convert to the mass. But again, there's no formula from mass to particles. We have to first convert to moles. We have to convert the number of particles to the number of moles, and then from the number of moles to the mass. Let's write down our information. Number of particles is 1.35 times 10 to the power of 28 NO2 particles. We want to find the mass. That's our unknown. To find the mass, you need the number of moles times the molar mass of NO2. And we can find the molar mass of NO2 using the periodic table. So we have the molar mass of NO2. What we're missing to use this formula is the number of moles. So what we need to do is convert the number of particles into number of moles. You can do that by doing the formula, number of moles is equal to N over Na. So we can plug that information into our formula, 1.35 times 10 to the power of 28 NO2s divided by Avogadro's number, which is 6.022 times 10 to the power of 23 NO2s per mole, particles of NO2 per mole. You can cross out NO2 and NO2, plug those numbers into your calculator, and you get 1.35 times 10 to the power of 28 in brackets, divided by 6.022 times 10 to the power of 23 in brackets, to 22,417 moles. 0.8 moles. So now we have to convert this mole value into mass. So our mass is going to be equal to our number of moles times our molar mass. Let me just double check our number of moles here. 1.35 times 10 to the power of 28 divided by 6.022 times 10 to the power of 23. That's right, 22,417.8. So our mass is going to be equal to 22,417.8 moles multiplied by the molar mass of NO2. So if you go in your periodic table, N is 14.01 plus 2 times 15.99 for oxygen, since there's 2 oxygens. So that's going to be equal to 45.99 grams per mole. Mole over mole cancels out. Then you can plug this into your calculator, 45.99 times 22,417.8 moles. And that's going to give you 0.622 grams.